Hi there, I'm going to go through Edexcel's A-Level Maths Pure 2 paper today from 2020. So question 1 is all about using the trapezium rule. We have a function given to us, y equals root x over 1 plus x, and we've already got a table of values for that. So the area of when we use the trapezium rule is equal to h over 2, and then it's the first ordinate plus the last ordinate, which is going to be 4 here, plus twice all the others. Okay, so what is h first of all? Well, we're going up by 0.5 each time, so h is 0.5. And then we just put in all the values, so 0.5774 plus 0.8452, that's the first and last, so that's y0, that's y4, and then plus twice the other ordinates. Again, if we put all that together, we get 1.50475, and we want an answer to 3 significant figures, so that's 1.50. Use your answer to part A, deduce an estimate for this. Well, what we've got an extra factor of 9 in there, so we can split that third up and write this as root 9 times, well, root 9 times part A. Root 9 is of course 3, so all we want is 3 times part A, so 3 times, and we'll use the full value, 1.50475. So that gives us a value of about 4.51. And then finally, we're told that to 4 significant figures, the actual value of that integral is 4.535. Comment on the accuracy. Well, if we compare that with our value, we can see that it agrees to 1 decimal place. Okay, and that's a statement that would suffice there. Question 2. We're told that P, Q, and R lie in a straight line, and Q is a third of the way from P to R. So let's just draw a quick diagram of this. So there's P, there's Q, and there's R. So Q about a third of the way along. And the position vectors of those are the lowercase p, q's, and r. So this is the origin. We've got P, Q, and R. That's what the position vectors are. They're the vector that takes us from the origin to that point. So show that this is true. Okay, so Q, so that's the vector that takes us from O to Q. Well, if we're going from O to Q, that's the same as going from O to P, and then a third of the way from from P to R. Okay. So O to P is just our vector P. P to R, right? What's that? How do we get from P to R? Well, P to R is the same as minus, P to O, and then O to R. So that's minus P, and then plus R. Let's put all that back together. So we've got minus P there, and then plus R. So P, and then minus a third P, that's 2/3 of P, and then plus a third R. And if we just take out the factor of a third and reorder these, we've got a third R plus 2P, which is what we were after. Question 3. Given that we've got this log equation, show that we end up with this quadratic. Well, all we need to do here is take in this coefficient as a power. So we get log of 4 minus x squared is equal to log of x plus 8. So then we remove the logs and we just get that. And if we just multiply that out, we're going to get 16 minus 8x plus x squared is equal to x plus 8. And then all you have to do is just rearrange to get the answer. Okay, so bring the x over and the 8 over, and we get that. Okay, write down the roots of the equation. So this factorizes into x minus 1, x minus 8. So x is equal to 1 or 8. State which of the roots is not a solution. Well, this is the problem term. We can substitute x equals 1 in there, but log of 4 minus 8, which would be log of minus 4, it's not defined. Okay, you can only have a logarithm of a positive number. So therefore, 8 is not a solution. Question 4. The binomial expansion of this, we're told that the x to the 4 term has a coefficient of 15120. Well, if we expand that using the binomial theorem, we get 8 to the power of 7 plus 7 choose 1 times 8 to the 6 2x and so on. So the term that we're interested in is going to be 7 choose 4 8 to the 3 2x to the 4. And we're told that that's equivalent to having a coefficient of 15120 in front of x to the 4. So we just need to multiply out that left hand side. So 7, so let's rearrange this. So 7 choose 4 a cubed times 2 to the power of 4, so times 16 is equal to 15120. So a cubed is equal to 15120 over 16 times 7 choose 4. And then we can work all that out in our calculator and we get a cubed is 27. So a is cube root 27, which is 3. Question 5. Two curves meeting, so we're just going to equate both of those. So 3 times 2x is equal to 15 minus 2 to the x plus 1. Well, 2 to the x plus 1 is the same as 2 to the x times 2. So we've got 15 minus 2 to the x. So if we add that term onto the other side, we've got 5 lots of 2 to the x is equal to 15. So 2 to the x is 3, and x then is log base 2 of 3. And that's all we need, the x coordinate. We don't need to find y. Question 6. We need to just do polynomial long division here. So x plus 2 into x squared plus 8x minus 3. So how do we do polynomial long division again? Well, we look at the highest degree term in the divisor compared to the highest degree term in the polynomial there. So x goes into x squared x times, and then we multiply that x by the divisor, so we get x squared plus 2x. Then we subtract, so the first term always vanishes. 8x minus 2x is 6x. Then bring the 3 down. Then repeat that, so we look at the x compared to the highest order term left, which is 6x. How many times does x go into 6x? It goes in 6 times. And then do the same again, so 6 times x plus 2 is 6x plus 12. And subtract minus 3 minus 12 is minus 15. Okay, so therefore A is 1, okay, 1x, B equals 6, and C equals minus 15. Hence, using algebraic integration to find the value of this. Okay, so just replace it with our expression. So we've got x plus 6 minus 15 over x plus 2 from 0 to 6. So integrate that. X integrates to x squared over 2, 6 to 6x, and then the last term is going to be logarithm, so minus 15 logarithm of x plus 2 from 0 to 6. Put in the values, so if I put 6 in, 6 squared over 2 is 18, 6 times 6 is 36, minus 15 log 8, that's the upper limit. The lower limit, I'm going to have 0 plus 0, and then minus 15 log 2. Oh, gone off the side of the page there. So 18 and 36 makes 54. Then I've got minus 15 log 8. Now the question asked me to give it in the form a plus b log 2, so I need to change that. So remember, log 8 is log of 2 cubed, and we can bring the 3 down to the front, so 3 log 2. So instead of minus 15 log 8, I've got minus 45, because of the 3 there, log 2. And then from the other bracket, I've got minus minus, so that's plus 15 log 2. So minus 45 plus 15 is minus 30. So minus 30 log 2. Question 7. Okay, so we've got this graph here with the equation 4x squared plus x over 2 root x minus 4 ln x. We just first of all need to find the derivative. Okay, so how do we do that? Well, let's just use the quotient rule. So it's v du, so the denominator times the derivative of the numerator. Then the numerator times the derivative of the denominator. So 2x to the half, the 2 and a half cancel, and we get x to the minus a half. Divided by the denominator squared. And then the 4 log x just differentiates to minus 4 over x. Okay, so the denominator, 2 root x squared, that's going to just be 4x. And then let's just multiply everything out. So 2 root x times 8x, that's going to be 16. Remember, root x is x to the half, so I can combine those powers to make this 3 over 2. Plus 2x 1 over 2. Then I've got 4x squared times x to the minus a half, so that's minus 4x to the 3 over 2 again. And then minus x times x to the minus a half, that's going to give minus x to the power of 1 half. And then the other term, just so I can put it over a common denominator, I'll just multiply top and bottom by 4. Okay, so it makes it 4x on the bottom there as well. So I'll bring everything together over a common denominator of 4x. So I've got 16x to the power to the 3 over 2, and I've got minus 4 of those, so I've got 12x to the 3 over 2. Then I've got 2x to the half minus another x to the half, so that's 1x to the half, and then I've got this minus 16 as well. So all I need to then do is multiply top and bottom by root x. So I'll get 12x squared plus x minus 16 root x over 4x root x, which is what I'm after. For P, show that the x coordinate of P is a solution of this. Okay, so that expression that we just had for the derivative, we need to set that equal to 0. And therefore, as it was a fraction, just the numerator must be equal to 0. So we get 12x squared plus x minus 16 root x is equal to 0. Okay, so we need to get it into this form. So what I'll do is I'll divide by 12. 16 over 12 is the same as 4 over 3. So that's looking similar to what I need, but I've got x over 12. I want root x, so I need to divide everything by root x. So I'll get x to the power of 3 over 2 plus root x over 12 minus 4/3 equals 0. So x to the 3 over 2 is equal to 4/3 minus root x over 12. And then I just need to raise both sides to the power of 2 over 3. Okay, so that's 3 over 2 to 2 over 3, they cancel, so that's just x. Okay, and then we're done. Then use the iteration formula with the first value of x equal to 2. Find the second value. So this is where you should use your calculator. So what I would do is I would put 2 into the calculator and then press equals, and that will store in the answer bit of the memory. That will store that as 2. And then what you want to do in your calculator is you want to do 4 minus 3 minus square root of the answer divided by 12 to the power of 2 over 3. Okay, so you press that button once, and that gives you x2 is equal to 1.13894. And then if you just keep pressing it a lot of times, eventually you'll see that to 5 decimal places it doesn't change anymore. And at that point you've got the solution that you're after. Okay, so if you just keep pressing the equal sign again and again and again, eventually you get a value of x equal to 1.15650. Question 8. We're told some facts about some function, so we're told its derivative, we're told its y-intercept, and we're told a factor of it. So first of all, if we've got its derivative, let's integrate it. So f is going to be the integral of the derivative. So if we integrate that, we're going to get 2x cubed plus ax squared over 2 minus 23x plus c. Okay, but we also know that the y-intercept is minus 12. Well, the y-intercept is where x is equal to 0. So let's just sub that straight in. So we've got f0 is equal to minus 12. So minus 12 is equal to c. Okay, just substituting x equals 0 into the function. So we've got f of x is equal to 2x cubed plus a over 2x squared minus 23x plus minus 12. We also know that x plus 4 is a factor. So using our factor theorem, that tells us that f at minus 4 is equal to 0. So let's substitute that in. So 0 equals function at minus 4. So minus 4 cubed is minus 64 times 2, that's minus 128. Minus 4 squared is 16 over 2, that's 8. So 8a. Minus 4 times minus 23 is plus 92. and then minus 12. Okay, and that's equal to 0, so 8a is equal to 128 minus 92 plus 12. What's that? 128 plus 12 is 140, minus 92 is 48, so a is 6. So therefore, f of x is equal to 2x cubed plus 6 over 2, which is 3, x squared, minus 23x minus 12. Question 9. I'll write this a little bit bigger. You might not be able to read it properly on the video. So we're told that the temperature of some ethanol is described by that model. So A and B are some positive constants defined. And we've also got some initial conditions. So remember, initial means t equals 0. So we've got the temperature when t equals 0 is 18. And we've also got this other boundary condition that when the time is 10 seconds, the temperature is 44. So if we substitute both of these boundary conditions into the formula, we get 18 equals a minus b e to the 0, which is just 1. And the other boundary condition gives us 44 equals a minus b e to the power of minus 0.07 times 10, so that's minus 0.7. So if we subtract one from the other to cancel out the a's, we'll get minus 26 is equal to, so minus b minus minus b e to the minus 0.7. I'll take out a factor of b there. So I've got e to the minus 0.7 minus 1. So therefore b is equal to minus 26 over that, which gives 51.6. And if we substitute that back into the first equation, which is easiest, a is equal to 18 plus b. So that's 18 plus 51.6, which is 69.6. So therefore we've got theta is equal to 69.6 minus 51.6 e to the minus 0.07t. Okay, we're told ethanol has a boiling point of 78 degrees Celsius. So use this information to evaluate the model. So if you keep heating it, eventually, if T is very large, then it should eventually boil. But in this model, when T goes to infinity, theta approaches, well, the exponential term, because it's decaying, the exponential term will tend towards 0. So the temperature will tend towards 69.6. Okay, so in other words, the maximum temperature this can reach is 69.6, not 78. So it doesn't model the boiling of ethanol. So we can say that it's a poor model. The max temp is very different. Okay, it's not even close to 78, so it's not very good. Question 10. Bit of trigonometric proving now. So cos 3a equals that. So how do we do that? Well, first of all, we use the compound angle identity. So 3a is equal to 2a plus a. And we can so expand that, cos 2a cos a minus sin 2a sin a. And then we'll use the double angle identities for cos 2a and sin 2a. So that's 2 cos squared a minus 1 times cos a minus 2 sin a cos a times sin a. Multiply that out. So the bracket 2 cos squared a times another cos a, so that's 2 cos cubed a, and then minus 1 times that. In the second term I've got sine squared, so I'm going to replace that by 1 minus cos squared. And then I've got another cos a there as well. So multiply that one out as well. So I've got minus 2 times 1 times cos a, so minus 2 cos a. Then I've got minus 2 times minus cos squared times cos a, so that's plus 2 cos cubed. Okay, and then last step then, just simplifying that, so I've got 4 cos cubed a minus 3 cos a. Okay, that's the first part. B, hence solve this equation. So let's use our identity. Whenever it says hence, that means the easiest way is to use the previous proof, what you've done in the previous step. So I've got 1 minus, so cos 3x we're going to replace by 4 cos cubed x, and then 3 cos x. Okay, so minus minus becomes a plus there. And sine squared, well, let's replace that by cos as well, so that's 1 minus cos squared x. So the 1 cancels on both sides, and then if I bring everything to the left hand side, I've got minus 4 cos cubed x plus cos squared x plus 3 cos x equals 0. Let's multiply by minus 1. So 4 cos cubed x minus cos squared x minus 3 cos x equals 0. We can take a common factor of cosine x out of all of this. And this will factorize as well. So 4 cos x, put cos x in there, and then we've got plus 3 minus 1. So we've either got cos x equals 0, so in the given interval, that must mean that x is equal to plus or minus 90. Or we've got cos x equals 1, so that just gives x equals 0 degrees. And then the middle one, cos x is equal to minus 3/4, so x is going to be plus or minus inverse cosine of minus 3/4, which is 139 degrees. So we've got 5 values there. Okay, the next one is a question that involves the modulus function. So we've got a sketch of a graph, 2 mod x plus 4 minus 5. And we're told that the vertex of the graph is here. Now at the vertex, the modulus, whether positive or negative, gives the same value. So at this vertex, we can say that x plus 4 is equal to, I don't even need the modulus signs there, the x plus 4 is equal to 0. So x is equal to minus 4. And if x plus 4 is equal to 0, then we've got y is equal to 2 times 0 minus 5, which is minus 5. So this point here is minus 4 minus 5. Solve this equation. Okay, so the easiest way to solve an equation is just to write down 2 equations with the modulus bars removed and either a plus or a minus put in front of it. So we get 3x plus 40 equals 2x plus 8 minus 5, or 3x plus 40 equals minus 2x minus 8 minus 5. On the left, if I move the 2x over, I get x is equal to 8 minus 5, which is 3, minus 40 is minus 37. Or I get 5x is equal to minus 13 minus 40 is minus 53. So x is minus 53 over 5. So it looks like we got two solutions, but with the modulus, we should always check that they're valid back in the original equation. And if you substitute this one back in to this equation, you'll find that you get left-hand side not equal to the right-hand side. So not a valid solution. So the only solution is this one, minus 53 over 5. Okay, the last part of this question, we're told that another line, y equals ax, okay, so that's a straight line through the origin, intersects our graph at least once. So let's just draw that again. So we had this. And this point here was minus 4, minus 5. So what we've got is we've got a straight line through the origin, and it intersects at least once. So there's two possibilities here. It could either be so steep that it meets here, okay, so that it crosses up there. So if that's the case, this line, this portion of the line is just 2x plus 8 minus 5. So this line has a gradient of 2. So if the red line is going to meet it at some point, then it has to have a gradient greater than 2. So a must be greater than 2 in that case. The other alternative is that we've got a line so shallow that it hits the bit of the curve down here. Okay, and it must be shallow enough that it at least hits the vertex point. So what we can say, and let's work out the gradient of that portion of the line there then, that bit of purple one. So just using delta y over delta x, we've got 0, minus minus 5, and 0, minus minus 4. So the line that would just hit the vertex would have a gradient of 5 over 4. Okay, so the gradient must be that's the most steep it can be, so it must be less than or equal to 5 over 4, or greater than 2. Notice it's not greater than or equal to 2, because if it was equal, the lines would be parallel and never meet. So we've got that. Now the question says give your answer in set notation. So the first inequality, we can say it could be anywhere between minus infinity and 5 over 4. But it can be equal to 5 over 4, so we indicate that with a square bracket. And the other alternative is greater than 2, so 2 and anywhere up to infinity. Okay, and it can be both of those, so we use the union symbol in between. So there's set notation. Question 12, parametric equations. So x is sine t, 6 sine t, y is 5 sine 2t. Show that the area of R is given by this expression here. Well, the area in parametric is y of t times dx by dt times dt between our two t values. So what are these first of all, what are the values of t that we're integrating between here? Well, these are still where y is equal to 0. So we've got 5 sine 2t, or just sine 2t equals 0. So that means that where's sine equal to 0? Well, when it's equal to pi, or where it's equal to 0. So t is either equal to pi over 2 or 0. So that gives us the limit of our integral, which is part of what we need to show. A bit hard to see, but 0 and pi over 2. So let's put everything else in now. So y is 5 sine 2t. dx by dt, so differentiate 6 sine t and you get you just get 6 cos t. Sine 2t, you can use the double angle formula to express that as 2 sine t cos t. And then 5 times 2 times 6 is 60. And then cos times cos is cos squared. So last step is just that we get what we're asked to find. Okay. Hence show that the area of R is exactly 20. So we need to do this integral now. And the easiest way to do that is using a u substitution. Okay, the reason why that works is because we recognize that we've also got something proportional to the derivative of u in that multiplying it. So du by dt is minus sine t. So du is equal to minus sine t dt. If we're making a substitution, we also need to change the limits. So when t is 0, cos 0 is 1. And when t is pi over 2, cos of pi over 2 is 0. So our integral becomes lower limit is 1, upper limit is 0. We'll put the 60 outside because it's just a constant. We also got a minus sign here, which will go outside. And then all we're left with is u squared du. Okay, so we've sine t dt we've replaced by du. So do this integral. U squared integrates to u cubed over 3. And then put the limits in. So we're going to get 0 minus a third. And if you simplify that, you get 20, which is what we want. Then we're told something about a dam. So part of this curve is going to be the profile of a small dam, x and y in meters. So the vertical wall of the dam is 4.2 meters high, and we've got this walkway here. Okay, there's somebody walking on it. So we need to find the width of that. So how do we go about doing that? Well, what we need to do is we've got that the y value at m and n is 4.2. So we need to find the t values at m and n. And then ultimately we'll use those to find the x values at m and n. So the y equation was 5 sine 2t. And we now know that that's equal to 4.2. So if we solve that, we get 2t is equal to, so inverse sine of 4.2 over 5, or, because we know when we do sine we always get two solutions, we get a secondary solution, which is pi minus it. So remember, if we find one solution, we've also got this one as well. So pi minus that. So if we divide by 2, we find two values of t, so we get 0.499 from the first one and 1.072 for the second one. So if we substitute those back into x now, so x was 6 sine t, then we get, in the first case, we get x is equal to, well, actually, let's just work out the difference between the x values. So we've got 6 sine 1.072 minus 6 sine 0.499, and that's equal to 2.4 meters. So the difference between them is that. Okay, and that seems like a reasonable answer, doesn't it? 2.4 meters for a walkway. So always think about, does your answer actually make sense? And seems to in this case. Okay, so now we've got another function which involves logarithms. The domain is x greater than 0, but x can't be equal to k. So why can't x be equal to k? Because that must be the value that makes the denominator equal to 0. We can't divide by 0. So that tells us that ln k minus 2 is equal to 0. So ln k is equal to 2. And if we exponentiate that, we get k is equal to e squared. Okay, that's part A done. Part B, prove that the derivative of the function is always positive. So let's use the quotient rule to do the derivative. So we need to multiply the denominator by the derivative of the numerator, which is 3 over x. Then subtract from that the numerator times the derivative of the denominator, which is 1 over x, and divided by the denominator squared. So that's just the quotient rule. Let's multiply out the numerator. So we get 3 over x ln x minus 6 over x minus 3 over x ln x, and then minus minus plus 7 over x over log x minus 2 squared. If we simplify that, we get the log terms cancel, and then we've got 7 over x minus 6 over x, which is just 1 over x on top, and then log x minus 2 squared on the bottom. Now the domain was x greater than 0. So if x is greater than 0, then 1 over x is greater than 0. Okay, so the numerator is always positive, and that term is also positive because a square is always positive. Okay. Square any number, you always get a positive number. Right. So that's enough to show that it's always positive. Last bit, find the range of values of a for which the function is positive, the function itself. Well, for this last bit, it could be the case that the numerator, so we've put x equals a in here, so the numerator is positive, and if we rearrange that, we get ln a is equal to is greater than 7 over 3, so a is greater than e to the 7 over 3. We also know that a is greater than 0, so we've got that as well. And it could also be the case that ln x is less than 2 as well, okay, to be positive. So ln a is less than 2, so a is less than e squared. So we've got a is greater than e to 7 over, so just to summarize that, a greater than e to the 7 over 3, or the other two are a compound inequality, so a can be between 0 or e squared. Okay, this is a question that really benefits from drawing a diagram. So we've got a circle which lies in the first quadrant, and it touches the x-axis and y-axis. So if it's only in the first quadrant and it touches them, then it must mean that it's tangent to the x and y-axis. So if it has a radius r, then that value there must be x equals r, and that value there must be y equals r. So the center of the circle is at r and r, lots of r's there. So the equation of the circle, x minus r squared plus y minus r squared is equal to r squared. And we're told that there's some line which intersects it. So if we rearrange that line into the form for y, we've got 12 minus 2x. So if we substitute that in to the circle equation, 12 minus 2x in there, then we just need to rearrange it to show that we get this. So let's multiply everything out. We get x squared minus 2rx plus r squared. The second one, you might just want to write out two brackets and do it a term at a time. But this gives, if you multiply that out, 144 plus 4x squared plus r squared minus 48x minus 24r plus 4xr and then that's equal to r squared on the right hand side. So what simplifications can we make? Well, let's cancel out an r squared here and here. We've got x squared and we've got 4x squared, so that's 5x squared. We've got minus 2rx and 4xr, so that's plus 2xr. We've got a minus 48x, and then the other terms don't involve x, so we've got r squared minus 24r plus 144. And then if you just factorize these two terms, you get what we're after. So part B says find the two possible values of r. So what we've got, if L is tangent to C. So there's two possibilities. Looks like that. But the important thing here is if you've got a line tangent to a circle, then we can write down that the discriminant of the quadratic is equal to 0. Okay? If it was positive, that's the case where it crosses at 2 points, and if it's negative, they don't intersect at all. So where it's tangent, that's equal to 0, so b squared minus 4ac. So just going back to this quadratic from the previous part, so a is 5, b is the bracket, and c is that bracket. So we just put all that together. So we've got 2r minus 48 squared minus 4 times 5 times that quadratic in r equals 0. Multiply all of that out. So I get 4r squared minus 192r Okay, so I get all of that. If I simplify that, I get minus 16r squared plus 288r minus 576 equals 0. I can divide everything by minus 16, so I get r squared minus 18r plus 36 equals 0. Then what I can do is I can just use the quadratic formula. So I get 18 plus or minus the square root of 18 squared minus 4 times 1 times 36 divided by 2. So I get 9 plus or minus, and if I put that all in my calculator, so the square root of all that divided by 2, I end up with 3 root 5. So they're the two values of r, 9 plus 3 root 5, 9 minus 3 root 5. Okay, next one, geometric series. So what we've got to do is we've got to prove the sum formula. So this is sort of a standard thing that you might remember doing when you first were introduced to this. So the sum of a geometric series, so the first term is a, and then every term in a geometric series is just multiplying by r. So a times r squared, times r cubed, all the way up to the last term, which is n minus 1. Okay, because remember the first term didn't have an r in it. So the nth term is n minus 1. And then what we can do is we can multiply every term by r. So we get ar plus ar squared plus all the way up to, and if we multiply the last term by r, we get ar to the n. So then what we'll do is we'll subtract the second sum from the first. So we get Sn minus Sn times r. And what happens is every term apart from the first on the top cancels out, and the last one on the bottom doesn't cancel either, so we get minus ar to the n. Then it's just a case of factorizing both sides. So the left hand side has a common factor of Sn, and the right hand side has a common factor of a, and then we just need to divide. Like so. Okay, then we're told that S10 is equal to 4S5. 4 times S5. So let's write that as an equation. So what we're just going to do is use the formula. So we've got a 1 minus r to the 10 over 1 minus r is equal to 4 times 1 minus r to the 5 over 1 minus r. Oh, 4a. So what cancels? An a cancels on both sides. The 1 minus r and the denominators cancel. So we're just left with 1 minus r to the 10 is equal to 4. Multiplying that out, 4 minus 4r to the 5. So if we move everything to the right hand side, we've got r to the 10 minus 4r to the 5, and then 4 minus 1 is 3. This is a quadratic. Okay. So if we put u is equal to r to the 5, then we just got r10, r to the power of 10 is just u squared. So we've got u squared minus 4u plus 3. And that factorizes into u minus 1, u minus 3. So u is 1 or u equals 3. Now u equals 1 gives r equals 1. Okay, and we're told at the start of the question that r can't be equal to 1, otherwise every term would just be the same. Okay, we'd be multiplying by 1 each time. Okay, so this is not valid, not a valid solution. So we must have u equals 3, which means that r is equal to the 5th root of 3. Okay, and that's the answer, only that. Okay, and then finally, last question, a proof. Use algebra to prove that the square of any natural number is either a multiple of 3 or one more than a multiple of 3. Well, first of all, any natural number can be written, so any natural number is either 3 times, let's say k, or 3k plus 1, or 3k plus 2. Okay, 3k plus 3 would be the equivalent of the first one again. Okay, so any natural number can be written like that. So if we square each of these, what do we get? So 3k squared, that's 9k squared, and that's a multiple of 3, because that's 3 times 3k squared. So that's a multiple of 3. If we got 3k plus 1 squared, then if we multiply that out, we get 9k squared plus 6k plus 1, which we can write, if we factorize the first two terms, we get that. So this is we can see this is a multiple of 3 plus 1. Okay, there's your multiple of 3 times some number. And then similarly the last one, 3k plus 2 squared is 9k squared plus 12k plus 4. And we can split that up into 9k squared plus 12k plus 3 plus 1. And then we can factorize, take a factor of 3 out of the first 3 terms again. Okay, so again we've got a multiple of 3 plus 1. Okay, QED. And that's it. Paper finished. Okay, so if you like that video, please press the like button and subscribe to my channel. If you want any one-to-one tuition, I also offer that in physics and maths at www.physicsmathstuition.com. Okay, thanks for listening. Bye for now.